This video is about quadratic word problems. So we're going to read the word problem and practice setting up the correct equation for you to solve. All of the ones that shows here, you can solve by factoring, which is what we've been working on lately. So for example, a town has a park that measures 400 meters by 600 meters. They want to double the area of the park by adding the same distance x to the length and the width. So we're going to write and solve an equation to find the new dimension. So what I'd like to establish first is what is the current area of the park? The current area is going to be 400 times 600. Okay, and the units on that would be meters squared. So this is the current area of the park, 400 meters by 600 meters, 240,000 meters squared. They want to double the area of the park, which means that they want their new area to be double that, so 480,000 meters squared. It's going to be the new area of the park. In order to obtain that new area, they want to add some number x to both the length and the width to give us 480,000. So we can base it on the equation area equals length times width. The area that we ultimately want to end up with is this. The new length and the width are going to be 400 plus x and 600 plus x. Because it says that we're adding the same distance x to both. And then this equation is going to be a quadratic equation that can be solved by factoring, although the numbers are fairly large. So we FOIL the two binomials together. Plus 400x plus 600x is going to be plus 1000x plus x squared. Subtract the 480,000 from both sides, and I'm going to rearrange this at the same time. Equals 0. And now we can solve this equation by factoring the left side. It's a little bit tougher to factor when you've got this many zeros attached to your C term, right? But you're looking for something that multiplies to make negative 240,000 and adds up to 1000x. So something that multiplies to that and adds up to 1000. I'm going to say, how about, I'm thinking of this too off the top of my head here. One's going to have to be positive and the other one's going to have to be negative. So I'm thinking positive 1200 and minus 200. Let's test and see if that works. So 12 times 2 is going to be negative 24. There's 4 zeros and it adds up to 1000. Okay, good. Here we have it. We're going to solve for x here. X is going to equal negative 1200 or 200. Now in this case, it doesn't make any sense to have a negative x value because we won't be adding a negative distance to the length and the width. So if x is 200, when we go back up and answer the question, it says write and solve an equation to find the new dimensions. The new dimensions of the park are going to be whatever 400 plus 200 is, and 600 plus 200, because we're adding x to both the length and the width. So the new dimensions of the park are going to be 600 meters by 800 meters. Okay? For this one, we'll just set it up and we won't go through the whole process of factoring and solving, because I think that's the part that you're most familiar with. But to set this one up, it says you have sewn a tablecloth that is 5 feet by 4 feet. So a tablecloth, that's a rectangular piece of fabric, 5 feet by 4 feet. It says you want to use 10 additional square feet of fabric, that's an area, to add a decorative border of uniform width. A decorative border of uniform width means you're adding a trim around the edges here. That's the same width all the way around. So this is the same as this, is the same as this, same as this. It looks sort of like a picture frame or the deck around the pool. That's another common one. And it wants us to figure out what the width of that border should be. So we're going to call that distance x, since that's the thing we are trying to find out. What we know right now is that the current area of the quilt is 5 times 4, which is 20. And the area of the, oops, I'll move that back into place. The area of the border, all this extra area here that I'm shading in blue, is the 10 additional square feet. So the total area of the whole quilt, including the inside part and the border, is going to be 20 plus 10. So our area is 30. To obtain the area of 30, it's the length times the width of the entire quilt, including the border. So our area of 30 has to equal the length of the quilt. Let's see if I can switch colors here. The length of the quilt, which is this. We have to find the expression that stands for this. Well, that part of it is 5, which we do because our original quilt had a length of 5. And we're adding an x and an x to either side because the border is extending in both directions. So the length of the quilt, when it includes the border, is 5 plus 2x. The width of the quilt is this dimension, which is the 4 plus an x on both sides as well. So 4 plus 2x. And again, this is going to be quadratic when we FOIL it together, and you can subtract 30 from both sides to make it say equals 0, and factor it and solve it. And then the third type that you might see is a revenue equation, which we have practiced before. We have a local newspaper with 28,000 subscribers when it charges $10, and they're thinking of increasing the price, which means they might lose some subscribers, but they can still do this to maximize their revenue. So remember that revenue is going to equal the number of subscribers or customers times the money that they pay for each item, or in this case for each subscription, the price. And we're talking about currently having 28,000 subscribers, but losing 2,000 each time they change the price. The current price is $10, and they're talking about increasing it $1 or maybe $2 or $3 or $4. They're trying to find that perfect amount. In this case, it's asking us how much they should charge to maximize the monthly revenue. So when you FOIL this out, you're getting a quadratic equation, or a quadratic expression, that has a negative 2,000x squared. And I'm going to save time and not FOIL out the rest of it. But what I want to illustrate is that when it's a negative, you know that that means it would be a parabola that looks like this. And so if it's asking you for a maximum in any quadratic word problem, you're looking for the vertex. We get the vertex using the negative b over 2a formula, and then plugging that back in to get the y value that goes with it, or in this case, the revenue value that goes with it. So you want to find the vertex if it's asking you for maximum or minimum. And we were, again, going to save time and not do that one. So that is all. Good luck with your homework.